Hey, how's everyone doing today? So today we're going to talk about mid-segments of a triangle. We'll define what that means, and then we'll also talk about some helpful properties. And then what we'll do is we'll try some problems, and hopefully you'll be able to go on and do some problems on your own to be successful. So let's go ahead and talk about first off the definition of a mid-segment. So the mid-segment of a triangle is just a segment that joins the midpoints of two sides of a triangle. So if we take a look over here, let's say we call this triangle ABC. We see this segment that connects sides AB and AC. If I call this point D and this point E, segment DE would be a mid-segment of triangle ABC, because as we can clearly see by the markings, point D is the midpoint of segment AB or side AB. Point E is the midpoint of segment AC or side AC. So DE is connecting the midpoints of those two sides. Now let's talk about some properties. So a theorem, the mid-segment of a triangle is parallel to the third side, and it's also half as long as the third side. So if we look back up at this diagram, DE would be parallel to BC. And then the other thing, actually we can just write that down here. So DE is parallel to BC. And what we also know is that DE is half the length of segment BC. And I'm not going to go through and do a rigorous proof of that, but we are going to apply those properties in just a minute. All right, so let's look at some example problems. Here, in example one, we know that P, Q, and R are the midpoints of the sides of triangle DEF. The first thing we want to try to figure out is what kind of figure is quadrilateral DPQR, and then what is the perimeter of that quadrilateral DPQR. So let's go ahead and label our diagram and see if we can answer these questions. So the first thing that we see again is that P is the midpoint of segment DE. So these two sides would be congruent. And if we take a look, DE is equal to 12 units in length. So that means that DP and PE would have to equal 6 units of length. We also see that R is the midpoint of one of the sides. So that means that DF is congruent to RF. And again, if we take a look, DF has a length of 8 units. So DR would have to equal 4, and RF would also have to equal 4. And then finally, Q is the midpoint of segment EF. So that means that FQ and QE are congruent. And then EF has a length of 10. So that means that these would be 5 units long as well. All right, so the first thing we're trying to figure out here is what kind of quadrilateral is DPQ. Well, if you notice, PQ is connecting the midpoints of segments DE and FE, which means that PQ is one of the mid-segments of triangle DEF. So PQ has to be parallel to the third side of the triangle. So the triangle. So it looks like PQ and DF would be parallel to each other. RQ would also be a mid-segment, again, because it's connecting the midpoints of segment DF and segment FE. So it would be parallel to side DE. Now, what we should be noticing here is that DPQR has 2 pairs of parallel opposite sides. So the answer to problem number 1 would be quadrilateral DPQR is a parallelogram. All right, and again, we figured that out because, again, RQ is a mid-segment of triangle DEF, so it's parallel to the opposite side, or this segment that contains that opposite side, and then PQ would be parallel to DR. So again, quadrilateral DPQR would have to be a parallelogram. Now the next thing that we need to figure out is what is the perimeter of DPQR. So what I'm going to do is I'm just going to outline DPQR real quick. So this is the figure that we're talking about, and we were talking about in the previous example as well. Now the perimeter, all we have to do is just add up the lengths of all the sides, or total the lengths of all the sides. So here, if you notice, we've got the lengths of two sides here are at 4 and 6. Now the opposite sides of parallelograms are congruent to each other, so that means that PQ would have to equal 4. Let me use a different color just because I was running out of ink, so this would be 4. And then RQ would have to be congruent to DP, which would be 6. Now we can also verify this by looking up here at this theorem that talks about midsegments. So the midsegment is half as long as the third side. So if we take a look, RQ, which is the midsegment, would have to be half of 12, and it is. And then PQ would have to be half of 8, which it is, it's 4. So again, all the things are kind of coming together here. So what is the perimeter? The perimeter of DPQR would have to be 6 plus 6 plus 4 plus 4. So it looks like that would equal 20 units. Okay, now let's take a look at a second example. Okay, so in example number 2, we're told that A, D, and C are the midpoints of triangle DEF. What we're asked to do is to find the length of CE, the length of DE, the perimeter of triangle DAB, and then the perimeter of triangle ABC. So let's go ahead and try and do this. So again, let's just check out this diagram here. So A is the midpoint of segment DF. That really doesn't help us figure out the length of CE. All right, so what I'm going to do is I'm going to look over here, and here's point C. So C is the midpoint of segment FE, which has a length of 26. So that means that CE would have to be half of that, would be 13, and FC would also be 13. So here CE has to be 13 units. DE, we'll go find that up here. So here's DE. Well, here we're given segment BE is equal to 12. Now, since point B is the midpoint, that means that DB also has to equal 12. So to find the length of DE, we're going to have to take the sum of these two parts, which would give us 24. So that means that DE has to equal 24. All right, let's try the next one. So here we're looking for the perimeter of triangle DAB. So I'm going to highlight that in green. All right, so again, to get the perimeter, we need to know the lengths of the three sides of that triangle. We know one of the lengths of the sides is 12, okay? Now what we need to do is figure out the lengths of the other two sides. And the way that I'm gonna do this is use that property of midsegments that we talked about earlier, where the midsegment of a triangle is half the length of the third side. So we'll find AB first. So if we look, AB is a midsegment, and the third side that it is parallel to has a length of 26. So that means that AB has to be half the length of that, which would be 13. Now AD, okay, that is going to be half the length of 23. So in this case, that would be 11.5. All right, so 23 divided by 2 would be 11.5, which is, again, the length of segment DF divided by 2. And now what we can do is we can add those three lengths up. So 11.5 plus 13 plus 35, that should be 36.5 units. And now the last thing that we need to find is the perimeter of triangle ABC. I'm just going to highlight that, in this case, in blue. So again, we know that one of the side lengths of triangle ABC is 13. Again, now we need to know the length of BC, and we also need to know the length of AC. AC, again, is a midsegment. It has to be half the length of this third side here, so half the length of DE. which would make that 12 units. And then BC again is a mid-segment, so it would be half the length of this third side, which would put it at 11.5 again. So again, if we add up those three side lengths, we'd end up with 36.5 units. All right, so now what you're gonna do, on the second page of this note sheet, there's a bunch of example problems. You're gonna go and try those on your own. I've posted the answer key for those problems to Google Classroom, so you'll check your answers after you complete those problems. I hope this intro video was helpful, and we'll see you in the next one.